Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our water flood learning. And today's topic is about dynamic map. All right, as previous videos, I will take the materials from this very good paper. Okay, let me change it to pen first. Okay, comprehensive evaluation of water flooding performance with induced fractures in a tight reservoir, a field case. Okay, so when you're handling a reservoir, especially a water flood reservoir, creating dynamic map is very useful and powerful. This is very helpful and it will guide us when we perform production analysis, reservoir performance analysis, and surveillance. And in particular, we have in front of us two maps, two dynamic maps. The first one is water cut map, and the second one is pressure map. And in particular, these are very important in water flood in tight reservoir. As you can see here, it's very clear that you have, the blue area for water cut map directing towards this, direction. You can see very clearly, right? Why? Because in this tight reservoir, based on the paper, we have induced fracturing, water flood induced fracturing. And you know that fracture will propagate at the direction of the maximum horizontal stress. And in this reservoir, the maximum horizontal stress is aligned towards this direction. So SH horizontal stress maximum. Okay. And if you have, let's say, injector here, and then it inject waters, continuously, it generates fractures. And as you go continuously injecting water through this injector, the fracture will propagate. And of course, at this area, the water cut will be greater than other area. So that's why you can see a clear difference between the water cut at this wing of the fracture zones, and the area, for example, right here. Okay, so this water cut map, especially in this reservoir case, is very helpful because it can, you know, it lets you know that, oh, I have induced fracture. That's first. I have a risk of connected direct connection between my injector and my producer. And this direct connection will be a problem. It will result in low sweep efficiency. It will result in early water breakthrough. It will result in water recycling. Okay, so it tells you that putting a new producer, for example, at this location is very dangerous. Okay, and it also gives you a very important. The second thing is it gives you the information where the area with low water cut, relatively speaking. Okay, so if you want to drill a new well or if you want to perform workover, of course you will select this area or maybe this area, maybe this area. All right. So whenever you are handling a reservoir, especially a water flood reservoir, and especially in tight reservoir, okay, generate water cut map. And the same thing with pressure map. Basically, you must create both of them, water cut map and pressure map. And very clearly, we can also see that the pressure profile is aligned with the water cut profile. Okay, let me change the color. Okay, now you can see here, the high pressure area is aligned at this direction. The same thing, maximum horizontal stress. Why? Because this is the area where the waters are. Okay, so of course at these areas the pressure will be greater than other area with less water, right? Okay, so yeah, that's the same thing. You generate water cut map, at the same time you generate pressure map. You input the latest data and you create time-lapse maps, both for water cut and pressure map. And it is very helpful surveillance tool. It gives you information that now you have a very clear proof that you have water flood induced fracturing. You can know, you can identify problematic injectors and producers that are in danger of water recycling, in danger of low sweep efficiency, early water breakthrough, and it can also give you the information of where are the areas with low water cut. But if you have low water cut, it is likely that that area will have relatively lower reservoir pressure. Okay, so it gives you the opportunity, but it also tells you the risk that you have. Okay, so I think that's all. I hope you enjoy this video. Again, if you're handling any reservoir, especially water flood in tight reservoir, you need to generate dynamic maps, production map, cumulative production map, and of course the water cut and pressure maps. Okay, thank you again and see you again in the next water flood videos. Thank you.